Well, welcome. Happy Friday here in algebra class. You got just about 50, probably even less than that now, minutes left of class, and we're on to the weekend, 3-day weekend. So hope you enjoy your 3-day weekend. We're going to do a video lesson here for Unit 8, Lesson 3. We're working it into the one and only Slope-Intercept Form. This stuff is the stuff of legends here. So Slope-Intercept Form would be in the form y equals mx plus b. That's something you'll probably have memorized at some point here in your math career. So y equals mx plus b, where m, if you remember from last lesson, is the slope. That refers to the slope, and b refers to, interestingly enough, I don't know why, there's some reasons I guess why it's called b, but you really just got to remember it's called b, but it actually refers to the y-intercept, meaning that where the line hits the y-axis. So it's always going to be 0, some number. So that number is actually what would then be the b here in the equation. All right, so an example, y equals 5x minus 3. Notice 3 here would be the slope, or 5 over 1. And then negative 3 would have to be the y-intercept, which means the point would be 0, negative 3, where it hits the y-axis. All right, so let's state the slope and y-intercept of each line. So the slope, once again, is the number with the x behind it. So the slope here would be negative 3. And the y-intercept, or the b value, would be 2, which means, of course, the ordered pair would be 0, 2. And then for the second one here, notice the negative 1/2 is in front of the x, so that's the slope. And then this was kind of an interesting one. You have to think, well, if there's no number after the x, what would that have to be? It'd have to be this kind of implied plus 0. So b here is actually 0, meaning we have the point 0, 0. All right, let's do some more. We're going to have 1x. Notice the implied 1, so slope would be 1. And then b value here being a negative 3, or 0, negative 3. And then over here we just have the 5. Notice it would have to be kind of a plus 0x, of course, that dropped out. So noticing here that the b value would be 5. That would be the y-intercept, or 0, 5. But the slope itself would have to be 0. All right, let's move on here. To graph the equation in slope-intercept form, we talked about this a little bit in the last lesson if you watched it. If you haven't, I'd recommend you go back and watch it. We're going to kind of hit some of those same concepts as building blocks for today's lesson. But you want to begin, the first thing you want to do is begin with a point. And in this case, we can begin with the y-intercept. That would be our starting location. And so we want to begin, and it's always going to be somewhere on that y-axis you're going to begin. Of course, the 0, whatever number that is in the equation as your y-intercept. So that would be where you start, and then step 2 then is to move the slope, moving your rise over run, or traveling the slope from that starting location. And so here's our 3 steps down here. So we're going to plot our y-intercept. From the y-intercept, you're going to then use the slope to move and get some other points. And lastly, of course, then you can draw the line through points. You typically just need a minimum of 2. But sometimes when you're doing it, it never hurts to maybe do it 2 or 3 times, just to kind of double check, make sure you didn't miscount. And also, if you don't have a straight edge and you're doing it on paper, actually doing it multiple times actually helps you make a straighter line. Fun fact. All right, so use slope and y-intercept to graph this one. So we got the slope here is 3/4, and we've got the y-intercept is negative 1. So let's start here at negative 1. And then from that point, we're going to count up 1, 2, 3, and over 1, 2, 3, 4. Okay, so that was up 3 over 4. There's 2 points right there. Just to kind of show you, if we wanted to add another point, I actually would run off the graph if I were to count up and over again. So I can't really do that. But you could actually do the same thing. You can kind of backtrack or reverse the whole thing. So instead of going up and to the right, we can actually go down 3. And, yep, it was 3, and then to the right, or to the left, in this case, 4. So that's kind of a way that you can always do the slope actually in the opposite direction. We typically don't do that, but sometimes you actually might have to if for some reason, you know, the next point would be off the graph or something like that. Otherwise, there's our line with 3 points. We only need 2, but there's 3 on that one. All right, next one here, same idea. We've got negative 3 would be the slope. Negative 2, or 0, negative 2, is the y-intercept. Let's go down to negative 2, and then a slope of negative 3 over 1 means I go, if you remember right from last lesson, that means I go 3 down and 1 to the right. So we're going to go 3 down and 1 to the right. Should put us right about there. And we'll draw our line. and that would be that one. All right, example 7. A slope of 0.5 means it would be the same as 1/2. Let's go ahead and just write it as 1/2. And then our b value is 4, so let's start at 0, -4. Put that on the graph. And then our slope would be up 1 over 2, up 1 over 2. So it looks something like that. All right, sometimes it may not be in slope-intercept form, which just means you have to rearrange it or solve for y to get it into slope-intercept form. So in this case here, if I want to solve for y, I got to think, well, what do I need to move here from the left side? I need to move the 4 as well as the 5x. Let's start with the 5x. So let's subtract 5x on both sides. We'll get 4y here is equal to -5x. I'm going to always typically write that first, because if you notice, our normal slope-intercept form, the x term is always written first before the number by itself. So I'm going to go ahead and write that 5x there first before the 8. All right, and then the other step we'll have to do is divide. And when you do this, you actually end up dividing every term, kind of like we were doing last unit. Divide every term by 4. So we'll get y is equal to -5/4. Fraction that we can't simplify, that's okay. We actually kind of like having a fraction for the slope. And then plus 8 over 4 would be 2. So let's start up at 2. We're going to go down 1, 2, 3, 4, 5, and over 1, 2, 3, 4. So somewhere around there. All right, so that would be that line rearranged here into our beloved slope-intercept form. All right, doing the same thing here. You'll kind of notice a trend on a lot of these. You typically will always move over the x first. Keep in mind that's a -3y. We get -2x minus 9 there. Divide both sides by -3. We get y is equal to a positive 2/3 x plus 3. Let's start up at positive 3. And we're going to go up 2 over to the right 3. And then that would be our line. All right, lastly here to end, to determine if there's a special relationship between the lines, sometimes maybe, sometimes two lines can be parallel with each other or perpendicular as well, two different things. Of course, parallel is where you have the two lines that go across like railroad tracks but never get closer or farther from each other. And perpendicular, of course, means kind of like a right angle or like a coordinate plane. They go at a 90-degree angle to each other, would be perpendicular. So those are kind of some special cases. So if they're parallel, it ends up being that they have the same slope. So that's something we can kind of be on the lookout for, kind of for that special case. And then if they're perpendicular, they're similar, but they're the specific relationship, they're opposite reciprocals. So if you think about opposite, that means the opposite sign. Okay, so opposite sign, but then the reciprocal means that you flip the fraction. So if it's the flipped version and it's the opposite sign, that's what we call an opposite reciprocal. Now you have to have both of those two things. If you just have the opposite sign but not the reciprocal, then it's not an opposite reciprocal. So make sure you have both of those things. All right, so we're going to see here, are the lines parallel, perpendicular, or maybe they're neither, which might be actually kind of most cases typically, but the ones that we see, we'll probably see plenty of those two situations. All right, so here, let's look at the slopes. That's really what we're trying to figure out. So we got a slope here of 1 on the first one. That implied 1 times x. That's, of course, not written, but it would be 1. And then over here, if you notice, in front of the x would be minus 1. So the slope here is negative, which if you think about it here, 1 over 1, you flip that over, add a negative sign, that would be -1 over 1. So in this case, we do have opposite reciprocals. So we're going to go with our final answer. We're going to go with our final answer here as perpendicular. All right, last example, same thing. On this one, to figure out the slopes, we're going to have to do just a little bit of work. So here's ones where if you notice, they're not solved for y. So let's go ahead and do that here real quick for each of these. All right, this first one would be what a 3/2, and we're really just only interested in the slope. Like this, I don't really care a whole lot about, at least at the moment. Let's figure out the other equation. All right, reducing this, we're going to get what, a negative 3/2 x minus 3. Once again, interested in the slope. Now, this would be the situation where they're opposite, but they're not reciprocal. So it's kind of this weird in between. They're not the same slope, right, because they have different signs, but they're not opposite reciprocals because they're the same 3/2, 3/2. So in this case, we have to go with neither. It doesn't really fit either pattern. So it's possible that you might have that. All right, and that concludes our video lesson here for today.